We'll take a 360-degree video of the chiller. These are the two slave modules. Module 2 on the right, Module 3 was on the left. You can see the hot dip galvanized lifting frame. Now we're coming over to the C1 panel end of the chiller. There's the C1 panel, transformer up above for the convenience outlet. This is the heat exchanger control box that will ship loose for mounting by Thermal Dynamics. We confirmed the power requirement to be 220 volt, 50 cycle, single phase with Mike Papke on the phone earlier. You also saw the 3 control valves, the 2 larger valves for isolation and the smaller valve is the bypass line. In the middle there you see the piping heading back through the walkway, that's the leaving connection. Now we're swinging around and you'll see the master module, panning up to see the condenser coil section, and then we'll come around and see the pumps. The chiller, as submitted, has independent circuits in each of the 3 mechanical modules. Here you see the 2 stainless steel chilled water pumps, the glycol mini feeder, and the expansion tank, standard pump control cabinet. And now we'll swing around to the right to see the entering connection, which is down there at the lower right. You just saw it with the pressure gauge right here. And then the leaving connection is on the background of the picture there. And there's the leaving connection with thermometer, pressure gauge. Down laying in the base of the pump module, you'll see the galvanized coupling for the entering connection. So that will ship connected to the chiller for use by Thermal Dynamics in connecting their field piping. A view of the connections from the expansion tank coming down there. This is the leaving pipe coming through the walkway, and now we'll swing over. This is the setup we used at the factory for phase loss testing, and now the junction box. 5 module breakers, 3, 1 for each mechanical module, 1 for the pump module, and 1 that feeds the C1 panel and the circuit breaker. Just a note here that there's 1 Corel controller in the master module. Because it's independent circuits and a smaller module, we're now spanning around to see the system entering water temp sensor that goes back to the single Corel controller, which is both the master and the slave. See the leaving spool piece here with the gauges, and you see the picture there of the hot dip galvanized coupling for the leaving connection. And now we're taking a video. You see the open bypass valve, and now I'll slide over. You can see the closed, you can see the shiny part of the closed part of the valve, and these are the isolation valves that come from the building loop. So now we'll slide over and observe the valve is closing and the isolation valves are now open, so they've stroked open. What caused that was placing the entering temp sensors into a cup of ice water. So now we'll pan over to see the sensors in the ice water and then into the heat exchanger control panel to see the indicator lights. So again, 2 isolation valves and a bypass valve all go in the building comfort cooling loop side of the heat exchanger. And now we're looking inside the control panel, and you see the green lights indicating that the isolation valves are open, and that PL5 there is the bypass valve that's closed, and that's because the temp sensors are in the cold water. You can now see the 35-degree entering water. And so when the water is cold enough from the comfort loop, we allow water to pass into the heat exchanger, and now the water's climbing into the 40s, into the 50s, and now we spin around to see that the bypass valve is stroking open. The isolation valves here are stroking closed, so they're already closed. Fairly quick acting actuator. And now we slide back, you can see that the bypass valve has now opened. So the bypass is short-circuiting water back to the comfort cooling loop, and then you can see that the indicator lights have flipped. The bypass valve open in green, and the 2 red lights up there indicate closed. So now just some measurement pictures. This is the entering connection at the pumps. This is distance above the bottom of our 6-inch lifting frame. And this is just a horizontal representation from you about 10.5 inches in to the far side of the piping. And then here's a height for the leaving connection, about 19 inches on center to that. It's a 3-inch connection at the leaving, and it's a 2-inch connection at the entering. And the last little note is that they are single feeds per phase, not parallel feeds. This chart shows that it's 1 aught for the 150 amp breaker, and then just a picture of the bottom of the inlet to the circuit breaker for the 1 aught wire, 1 per phase.